massive new interstellar traveler has entered our solar system. An object so immense and brilliant that astronomers describe it as nearly 100 times larger and more luminous than 3I Atlas. First detected on September 12, 2025, using the SWAN instrument aboard the SOHO spacecraft. Its discovery immediately set off a chain of global observations. Within 48 hours, Australian comet hunter Michael Matiazzo captured a stunning image that left scientists speechless. This wasn't just another visitor from the void. It was something entirely different, a spectacle blazing toward the sun with a ferocity that dwarfs every known comet sighting in recent memory. Its sudden appearance has already ignited debates among astronomers, some calling it the most significant interstellar object discovered since Oumuamua. Others suggest that its timing, arriving just as 3I Atlas closes in on its own solar encounter, cannot be coincidence. Its physical features are just as astonishing. The newcomer's tail stretches nearly 2.5 degrees across the sky, roughly 5 times the width of the full moon as seen from Earth. Against this dazzling sweep of light, 3I Atlas's own thin filament of a tail looks almost insignificant, like the trail of a lone matchstick compared to a wildfire. The sheer scale of this tail indicates a tremendous release of material or energy, far beyond what a typical comet would produce. Some astronomers have even speculated that this might not be simple outgassing from solar heating, but a more controlled or directed phenomenon. Its brightness and sharply defined tail make it one of the most visually striking objects ever captured by amateur and professional telescopes alike, a glowing spear cutting across the cosmic dark. The International Astronomical Union moved quickly to classify and name the object, granting it the designation C/2025 R2 SWAN after its instrument of discovery. Initially known as SWAN 25b, its formal naming cemented its place in the astronomical record. But naming it did little to quiet the questions. Unlike 3I Atlas, which hails from a region near the galactic core, SWAN's origin point is radically different. It came screaming in from Aquarius, a completely unrelated trajectory, making the idea that they are fragments of the same body virtually impossible. This independence deepens the mystery. Two unrelated interstellar objects, arriving in our solar system within months of each other, and both on course to meet the Sun at nearly the same moment. For many in the scientific community, this coincidence strains belief. Could two such wanderers really appear back-to-back after eons of silence? Or are we witnessing something coordinated, some cosmic event larger than we understand? This sense of timing is what troubles astronomers most. SWAN will make its closest approach to the Sun, its perihelion, at a distance of about 150 million kilometers. Just days later, 3I Atlas will pass at 203 million kilometers. On a cosmic scale, the difference is razor-thin, barely 50 million kilometers apart, and the gap is narrowing as gravitational forces subtly alter their velocities. For a brief moment in October 2025, the two objects will disappear from every Earth-based telescope, swallowed by the blinding glare of the Sun. When they emerge again, their paths may be forever changed, or one may not reappear at all. Astronomers are bracing for what could be an unprecedented natural experiment. Two interstellar travelers, possibly communicating, maneuvering, or even colliding beyond our sight. Whatever happens in those hidden weeks near the Sun could rewrite what we know about comets, interstellar matter, and perhaps even intelligent design in the universe. As both interstellar objects close in on the heart of the solar system, the timing becomes increasingly eerie. SWAN's perihelion, its closest approach to the Sun, will be roughly 150 million kilometers, practically the same distance as Earth's orbit. Just a few days later, 3I Atlas will follow on its own path, passing the Sun at about 203 million kilometers. The gap between them, barely 50 million kilometers, might seem vast by human standards, but on a cosmic scale, it is the equivalent of two bullets passing within inches of one another. Even more unsettling is the fact that during this crucial moment, both objects will vanish from view, hidden behind the Sun's blazing disk. For weeks, no telescope on Earth will be able to track them. It is as though the universe itself has drawn a curtain, leaving humanity blind to whatever is about to unfold. Astronomers are preparing for this blackout with a mix of dread and anticipation. When the two visitors reappear on the other side, their courses may be drastically altered, revealing whether they interacted gravitationally, or perhaps in ways no one expects. Will they accelerate, decelerate, or shift trajectories entirely? Some even speculate about the possibility of a near-miss encounter, or, more dramatically, a collision. If either object fragments near perihelion, the resulting debris could shower the inner solar system, creating a spectacular meteor display, or a hazard to satellites and spacecraft. Whatever the outcome, the October window represents a once-in-a-lifetime alignment, and its implications may extend far beyond astronomy. What is most disconcerting, however, are the properties these objects appear to possess. Data from 3I Atlas has already shaken the scientific community. Spectroscopy suggests its composition is dominated by pure nickel, without the iron content normally found in natural meteoritic material. This unusual makeup alone would be enough to spark debate, but it is the energy readings that have truly alarmed researchers. Instruments have measured emissions consistent with a sustained 10 gigawatt power source buried deep within the object, comparable to 50 nuclear power plants operating in unison. Even stranger, its tail does not behave like ordinary cometary outgassing. Instead of a chaotic spray of sublimating ice, its emissions form a narrow, collimated jet, as if under deliberate control. The flow is constant, maintaining a fixed velocity, and at perihelion, its color abruptly shifts from red to green, an event that Harvard astrophysicist Avi Loeb calls thrust modulation. In his view, the object is not merely venting gas but actively steering, adjusting its trajectory as solar heating increases. If 3I Atlas resembles a probe, SWAN R2 is something far more formidable. Early observations indicate a sheath of highly ionized plasma surrounding its core, creating a shimmering barrier capable of deflecting charged particles from the solar wind. Unlike a passive cometary coma, this shield seems to fluctuate dynamically, almost as though it were being tuned in real time. Its vast, luminous tail, spanning 5 full moons, suggests immense power behind its emissions. Even more astonishing, small periodic changes in brightness have been detected, hinting at bursts of controlled propulsion. These light pulses match what would be expected from a high-efficiency plasma drive, gently but precisely nudging the object along its path. Spectral analysis further revealed traces of nickel-cobalt plasma mixed with carbon dioxide and carbon monoxide, a chemical cocktail that does not match any known natural process. Producing such a mixture would require temperatures and magnetic confinement beyond anything that occurs spontaneously in comets. And then there is the core itself. If 3I Atlas's 10 gigawatt output was shocking, SWAN's core is staggering. Its energy levels are calculated to exceed 10,000 gigawatts every second. To put this in perspective, that is nearly the total power consumption of human civilization, compressed into a single interstellar machine. Some theorists compare it to the energy release of merging black holes, scaled down but perfectly contained. In their words, if 3I Atlas is a scout, then SWAN is the fortress, a leviathan crossing the void on a mission that defies easy classification. SWAN's core is claimed to output more than 10,000 gigawatts every second, an amount of energy so staggering that it dwarfs the entire electrical consumption of Earth by orders of magnitude. This is not a mere cometary nucleus, it is a controlled power source, a reactor humming at a level we can scarcely imagine. If such a device truly exists, it implies technology capable of sustaining, regulating, and containing energy on a scale that rivals cosmic events. The idea that an object could traverse interstellar space, survive for tens of thousands of years, and then activate or brighten precisely as it nears our sun suggests a system that is not just durable, but intelligent. The plasma surrounding SWAN flares like a living organism, bending the solar wind around it as though shaping its own environment. Observers describe its behavior as reactive, almost as if it is aware of its surroundings and responding to changing conditions. When its brightness pulses in measured intervals, it feels less like random outgassing and more like communication, or at the very least, an operational cycle. To some, this object is no longer just a visitor from another star system. It is an engineered presence, a vessel with purpose, arriving at a predetermined time. Its orbital characteristics add to the mystery. NASA and JPL calculations suggest that SWAN is not a one-time interloper like Oumuamua, but rather a returning traveler, locked in a cycle that spans roughly 22,554 years. That means the last time it passed near the Sun, humanity was emerging from the last ice age, just beginning to experiment with agriculture and building the first stone monuments. If this data is correct, then SWAN has visited before, perhaps many times, each appearance separated by gaps so wide that entire civilizations have risen and fallen in the interim. The thought that such an object has been quietly threading the same path around our star for longer than recorded history raises unsettling questions. Is this merely a natural orbital resonance, or has the trajectory been deliberately maintained for eons? This is where the speculation begins to eclipse the science. Many researchers now argue that we may not be dealing with a simple comet at all. Instead, these objects might be autonomous probes, self-repairing, self-navigating, built to operate on cosmic timescales. 3I Atlas, with its strange nickel composition and controlled exhaust, could have been a scout, sent ahead to survey or transmit data. SWAN, with its overwhelming power output and plasma defenses, might be the follow-up. A larger, more capable craft arriving to retrieve information, replenish resources, or complete some mission set in motion thousands of years ago. To civilizations capable of such feats, the passing of millennia would mean little. For them, returning every 22,000 years could be no different than a routine service call, a scheduled maintenance trip through the inner solar system. The possibility that this is a coordinated mission adds a chilling dimension. Some theorists propose that SWAN could be here to recover 3I Atlas, either absorbing its data, dismantling it, or even neutralizing it if its mission has concluded. Others argue that these objects may not even belong to the same faction. What if they are rival probes, converging on the Sun to fight over some resource we cannot yet comprehend? Its magnetic field, gravitational lensing potential, or raw energy output. To them, our star might be a cosmic beacon, a power station, or a gateway to something far beyond human perception. Whatever the truth, the convergence of two interstellar machines within days of each other feels less like coincidence and more like choreography. Something is happening on a scale so vast that we are only now catching a glimpse of the pattern. Some researchers have gone further, proposing that humanity's most enduring monuments may not be mere works of art or religious devotion, but cosmic records, encoded warnings from an era when our ancestors may have seen similar objects blazing across the sky. The last time SWAN R2 is believed to have passed near the Sun was roughly 22,000 years ago, at the end of the last ice age. This coincides with one of the most dramatic shifts in human history: the sudden appearance of agriculture, monumental stonework, and the first attempts at star mapping. Structures like the Great Pyramid, Göbekli Tepe, and the perfectly aligned megaliths at Stonehenge have long puzzled archaeologists for their extraordinary precision. Many of these sites contain shafts or alignments that point toward key stars and constellations, most notably Orion. Were these builders merely fascinated with the night sky, or were they marking a recurring event they had witnessed firsthand? The idea is chilling. An ancient civilization, perhaps far more advanced than we imagine, observing a celestial visitor with a blazing tail spanning 5 moons across the heavens. They may have understood that it would return, not in years or centuries, but in cycles so long that they needed to carve the memory into stone itself, leaving a message for distant descendants who might be alive to see it again. The pyramid shafts, the stone circles, even ancient calendars tracking precession could be more than cultural curiosities. They might be beacons, warning us when the next cycle begins, when the sky will once again host these great travelers. If this is true, then what we are witnessing is not random at all. It is the continuation of a pattern known to humanity for millennia, forgotten and rediscovered only when the cycle repeats. Adding to this sense of unease is the timing of modern events. In the past decade alone, we have seen three major anomalies. Oumuamua in 2017, the first known interstellar object to pass through our solar system. 3I Atlas, with its unnatural nickel composition and nuclear-like power core. And now, SWAN R2, which seems even more formidable. Harvard's Avi Loeb and others have suggested that this may not be a coincidence. For over 50 years, humanity has been leaking signals into space. TV broadcasts, radio transmissions, planetary radar, and intentional messages like the Arecibo signal and the Voyager golden records. These transmissions have by now washed over dozens of nearby star systems, forming an ever-expanding bubble of electromagnetic noise. It is possible that we have, unknowingly, announced our presence to whoever or whatever listens in the dark. If so, what we are witnessing now could be the response. First came Oumuamua, silent, dark, and fast-moving, as though it were simply observing. Then came 3I Atlas, its behavior far more active, perhaps gathering detailed data or even testing its environment. And now, SWNR2, a vast and heavily powered craft that feels less like a scout and more like a command ship. If this is indeed a sequence, then we may be living through first contact, not in the way science fiction promised us, with greetings and landings, but in the form of an audit. A civilization might not respond with words. They might respond with machines, dispatched across the gulf of space to examine, to measure, to decide. And as both objects disappear behind the sun in October, humanity will wait, blind, for what emerges on the other side. Perhaps they will simply pass and vanish into the void, leaving us with more questions than answers, or perhaps their course will change, and their mission will truly begin. What is perhaps most unsettling is the silence. Despite the scale of these discoveries, there has been remarkably little public discussion from the world's leading space agencies. NASA, ESA, JPL. None have offered more than cautious statements, and no government has moved to treat these converging events as matters of global concern. It is as if, collectively, humanity has decided that the less we acknowledge, the less we must face. But silence does not make the cosmos any less active. The sky continues to deliver its messages, and these objects continue on their trajectories, indifferent to our reluctance to confront them. This quiet is dangerous. If these are natural phenomena, we stand on the verge of one of the greatest scientific breakthroughs of our age, witnessing, in real time, interstellar travelers that could teach us about the origins of our galaxy and the building blocks of distant systems. If they are not natural, if their motions are controlled, their emissions deliberate, then we are staring at the first undeniable evidence of technology older and more advanced than anything we have ever imagined. In either case, ignoring the implications means missing a moment that could redefine what it means to be human. Our categories of understanding are breaking down. The line between comet and craft, between astronomy and archaeology, is blurring. We may need new language, new frameworks, perhaps even a new philosophy to comprehend what we are seeing. These objects challenge the very idea that we are passive observers in a quiet universe. They hint at a larger narrative, one in which our solar system is not an isolated outpost, but part of a network, a stage on which dramas have been unfolding for far longer than we have existed. The risk is not that we overreact. The risk is that we fail to react at all, that we dismiss the signs, close our eyes, and allow this moment to pass without learning its lesson. The cosmos is speaking, whether we choose to listen or not. Perhaps this is not just an astronomical event, but an invitation, a test, or a warning. If this is the beginning of a new chapter, then we are all witnesses. So as October approaches, and these two travelers vanish behind the sun, pay attention, watch with us, question everything, and prepare for what might emerge on the other side. And if you believe these events demand more than silence, share this story. Leave your theories in the comments, and subscribe for more deep dives into the mysteries unfolding above us. The next few weeks could change everything we think we know about our place in the universe.